Okay, so we're going to see trigonometric ratio and identities. So we look at our ratio first. So how many trigonometric we have? We have sine. We have trigonometric sine, cos, tangent, cosecant, secant, cotangent. Alright. So theta, it can be anything theta. So for how we define sine, cos, tangent, cosecant, secant, and cotangent. So we were referring to triangle. Anything we're referring to the triangle. So for an acute angle theta, so when your theta is here, your opposite will be defined as your length of y. So where's your opposite length? Here is your opposite. Because you look at your theta here, and this is your triangle. When your theta here, opposite is y. Adjacent length will be x. And then hypotenuse, the longest side of our triangle, will be z. So when you have a theta here, means opposite angle here will be 90 minus theta. So why 90 minus theta? Because in a triangle, we will have 180. Minus one of the angle is 90. And then 1 minus this angle is theta. So means the angle at these vertices will be 90 minus theta. Okay, so we look at the trigonometry ratio first. So for sine, definition will be opposite over hypotenuse. So we have y over z. So for cos, it will be adjacent over hypotenuse. So that's why we're having length of x over z. Then tangent, opposite over adjacent. So we will have length of y over x. Meanwhile, for cosecant, so cosecant, how they get this? So cosecant, it will be equals to 1 over sine theta. So the theta will be together with trigo. The theta will not separate out from the trigo. It will not be like this. Alright? It like log. Dia macam log. Log tepi sentiasa ada benda. Ada equation kan? So trigo tepi sentiasa diikuti oleh angle dia, theta dia. So bukan. So kamu tak akan nampak sine macam ni je. Kamu tak akan nampak cos macam ni je. Tak ada. Always having a theta within, dibawa dengan dia. Okay. So bila kita nak buat cosecant, kena buat dengan betul lah. So cosecant will be equals to 1 over sine theta. So sine theta just now is 1 over y over z. 1 over y over z. Simplify this. Z over y. Why become like that? Because 1 divided by y over z equals to 1 times inverse the fraction z over y. So it becomes z over y. Okay? Okay. So how about second? How about second? It is equals to 1 over cos theta. So 1 over just now cos theta is x over z. So 1 divided by x over z, inverse it will become 1 times z over x. So answer z over x. Alright. So cotangent, 1 over tangent. So tangent is y over x. So we simplify this fraction, we get x over y. So in trigonometry, we will have 6 trigonometric functions. Basically, this is the 3 basic, and then cosecant, secant, cotangent is derived from the sine, cos, tangent. Okay, then from the diagram, example 1, it said cotangent is 3 over 4. So cotangent is derived from tangent, right? We simplify first. What's mean by this? If you're having a cotangent is 3 over 4, it means that 1 over tangent is 3 over 4. We simplify our cotangent by substitute back 1 over tangent. So what is your definition for your tangent? 4/3. Then we know that in our right angle triangle, if our theta is here, tangent is referring to opposite over adjacent. So opposite length will be 4, adjacent length will be 3. How about its hypotenuse? So hypotenuse will be using Pythagoras theorem, a square plus b square and square root, you get 5. Okay, so refer back to the definition here, then we find out all the tangents. So tangent, indirectly we found already. So how about your sine theta? Opposite over hypotenuse. Second theta, 1/cos. So it will be 1/, cos will be adjacent over hypotenuse, 3/5. So it will be 5/3. Then cosecant theta equals to cosecant 1/sine. So sine is 4/5. Inverse it, you'll get 5/4. Okay, so this is how we find all the trigonometric value using your right angle triangle.